With constant practice, nor do we learn how to locate points on the Cartesian plane, but by observing the ordered pairs, we can say that in which quadrant it will lie. If you look at my screen, here are given set of points. We need to locate them on the Cartesian plane. But I would first like you to try just by merely observing this point that in which quadrant will they lie. Looking at the first point 5, 0. 5 is my abscissa, 0 is my ordinate. So what do we see? That both the abscissa and the ordinate, they are positive. Both the abscissa and the ordinate, they are positive. And clearly this point must lie in the first quadrant. Let us check our answer. Let us verify that whether I have detected the correct quadrant or not. The abscissa is 5 units to the right. So my abscissa is what? It is the horizontal distance. So the horizontal distance is at 5 units and the vertical distance is at 0. So this point will lie on the x-axis. It is lying on the x-axis, that it is neither lying in the first or the second or the third and the fourth quadrant. So here I went wrong because 0 is neither positive nor negative. So here I need to correct myself and I'll be introducing a new concept. Since this point lies on the x-axis, since this point lies on the x-axis, the value of y is 0. Such a point where the value of y is 0 will always lie on the x-axis. So a point of the form x, 0 is a point on x-axis. So we cannot say that it is lying in the plane or in the quadrant. It is lying on the axis. Similarly, if I look at the second point, it is of the form 0, y. Here the value of x is 0. Let us try to locate this point and cross-check our answer. So if I have x as 0, x is 0 here at the origin and the value of y is 5. So 0, and if I take vertical distance 5, my required point lies on the y-axis. So from here we conclude that a point on y-axis will be of the form 0, y. So if the x coordinate is 0, the point lies on the y-axis, and if the y coordinate is 0, the point lies on the x-axis. So they are not lying in any specific quadrant, they are lying on the line, either on the vertical or the horizontal line, that is either on both the axes. If I look at the third point 2, 5, here both the values of x and y are positive and they will obviously lie in the first quadrant. Let us locate this point. 2 is the horizontal distance, so horizontally moving, I'll mark a horizontal distance, and vertically I have to vertically move 5 units upward. So finally my point will rest here. I'll introduce you to a new term. If I'm moving horizontally, I name it run, and when I'm moving vertically, I will name it rise. So a coordinate is nothing but a combination of rise and run. So what do I see? I have moved 2 steps, I have run 2 steps to the right, and I have risen 5 steps upward. So finally my point rests here, which is 2, 5 and lies in the first quadrant. So the word rise and run is very important. Rise can be a positive rise or a negative rise. If I may climb downwards or I may go upwards, but I use a single term rise for that. Run, I can move to the left or to the right. Moving to the left means negative value and moving to the right means positive values. Now, if I look at the third point, again it rises in the first quadrant and we have seen it, and let me locate the point. So, 5 units to the right, that means I am running 5 steps to the right and I am rising 2 units upwards. So, this is my point 5, 2 and it is lying in the first quadrant. Minus 3, 5. Minus 3, 5, x is negative, y is positive. Where is x negative? X is negative on the left side. And where is y positive? Y is positive upwards. So, obviously, this point must lie in the second quadrant. And if I locate this point, minus 3 means running 3 steps to the left and rising 5 units upward. So, this point will be my minus 3, 5. 3 to the left and 5 upwards. That is running 3 steps to the left and rising 5 units upwards. Minus 3 minus 5. We are running 3 steps to the left and we are climbing down 5 units. That means here both x and y are negative, and we have already learned that both x and y are negative in the fourth quadrant. Let us check the answer whether I have located the point correctly. In the fourth quadrant, if I see minus 3 lies here. If I take the horizontal distance, minus 3 would come here. And if I go vertically downwards, minus 5 would come here. So, finally my point rests in the third quadrant. Finally, my point rests in the third quadrant. Five and minus 3. X positive, y negative. X positive and y negative, it lies in the fourth quadrant. So, in the fourth quadrant, let us see whether I have placed the point correctly or not. 5 units to the right and 3 steps down, and my point finally rests in the fourth quadrant. Similarly, 6 and 1, both x and y are positive, and this we have already seen lies in the first quadrant. So, 6 steps to the right, 6 steps to the right and 1 step above. So, finally my point will lie here. So, by this exercise, we have not only learnt how to point a coordinate on the Cartesian plane or how to locate the position of a point on a Cartesian plane, but also by observing the points, we can quickly say that in which quadrant it will fall. Also, we have learnt one more thing, the point on the axis. If the x coordinate of a point is 0, then the point will lie on the y axis, and if the y coordinate of a point is 0, then it will lie on the x axis. Now, let us quickly recap whatever we have learned. We started with a horizontal number line and name it x dashed with 0 as the origin or the midpoint of the number line. Now, when I tilt it, tilted this number line upwards, we'll get a vertical number line. So, before we move to the vertical number line, let me locate few points on it. The points to the right of the number line will have all positive values, and the point to the left of the number line will have all negative values. And we know as we move to the left, the values keep on decreasing. That is why minus 2 will always be less than minus 1. Minus 3 will be less than minus 2. And minus 4 will be less than minus 3. So, very important point to note that as the absolute value means the number of steps that we are taking to the left or to the right. As the absolute value towards the left of the number line increases, the value of the number decreases. So the absolute value of -3 is 3, because 3 steps to the left is obviously less than 2 steps to the left. Now if I tilt the number line vertically, I'll get a line like this, and I'm tilting it in which direction? In the anti-clockwise direction. And I name it as y dashed. Y dashed and x dashed are towards the negative side of the number lines. So this vertical number line is the y-axis. This part of the y-axis, that is above the origin O, will have all positive values, and below the number line, vertical number line, I'll have all negative values. So x dashed is my x-axis, y dashed is my y-axis. Both are together known as, coordinate axis. Now, as I have drawn both the number lines, I can see 4 regions on the Cartesian plane. The Cartesian plane is the entire area that I am covering. The first region is known as first quadrant. We are moving in this direction. We tilted the number line in the anti-clockwise direction, so my first quadrant lies here. This is my second quadrant. This is my third, because we are moving in the anti-clockwise direction, and this is my fourth quadrant. Next, about the sign of the ordinate and abscissa and how are they written. All the x values, they are known as abscissa, and all the y values, they are known as ordinates, and these together, they are known as coordinates. They together are known as coordinates. Now, how do we locate these coordinates and how do we write it? We write it as in the form of an ordered pair x comma y. The order is x comma y. The value of x is written first and the value of y is written later, or abscissa first and ordinate later. So if I go by this ordered pair, then in the first quadrant I will have x positive and y also positive. In the second quadrant, x is negative and y is positive. In the third quadrant, both x and y are negative. In the fourth quadrant, x is positive whereas y is negative. Next comes the location of a point. If I have to locate x, suppose I choose a point here and I have to locate it, then the horizontal distance, this will give me the value of x, and the vertical distance, this will give me the value of y. So here if I see the horizontal distance, the horizontal distance is 2 units to the right. So the x coordinate will be 2 and the vertical distance is 2 units again. So 2 units from 0 to 2, that is 2 units upward. I told you this is my run and this is my rise. This is the best way of remembering the x and the y coordinate, x for run and y for rise. So if I am saying rise, it could be a downward fall also at times. Although we are using the word rise, which means climbing up, but in mathematics or in coordinate geometry, rise is not, if it's a negative rise, obviously it's a downfall. So this is the way we locate a point on the Cartesian plane. Now next comes a point on the axis. It is, as I can see, there are points on the axis also. It is not necessary that every time I locate a point in the 4 quadrants. Sometimes the points may be located on the axis or on the number lines as well. For example, if I choose, suppose if I choose a point here, which is on the positive side of the y-axis, what do I see? What is the horizontal distance? I am not running at all. I am just rising. And if I am not running, that means the horizontal distance is 0. And how much I am rising? I am rising 4 units up. That means positive 4. Similarly, if I choose a point -3 on the y-axis, I am only climbing down or moving down. There is a downfall and I am not running at all because I am neither moving to the left or to the right. So if there is no horizontal distance covered, again the x coordinate will be 0 and the y coordinate will be -3 because I am having a negative rise or simply downfall. Again, if I choose a point on the x-axis, what is the horizontal distance? The horizontal distance is from 0 to -2. That is, I am running 2 steps towards the left. So my run is -2. But what is my rise? I am only moving in a horizontal way. I am not at all climbing up or moving down. So here the value of y will be 0. Similarly, if I choose a point here, I am running 3 steps to the right. So the x coordinate will be 3 and I am not climbing up or down. So my y value will be 0. So with this summary, I have covered everything which you need to know in coordinate geometry of grade 9. Let us summarize it once again. So to locate the position of an object or a point in a plane, we require perpendicular lines. One of them is horizontal, known as the x-axis, denoted by xx dash, and the other vertical line denoted by yy dashed. And the 2 lines along with the 4 quadrants, it is known as Cartesian plane. And why it is important to learn this? Just to locate a point on the plane. The plane is called the Cartesian or the coordinate plane and the lines are called the coordinate axis. Axis is the plural of axis. The horizontal line is called the x-axis and the vertical is known as the y-axis. The coordinate axis divides the Cartesian plane into 4 quadrants or regions start in an anti-clockwise direction, first, second, third and fourth. The point of intersection of the two axes, that is the y-axis and the x-axis, is the point 0, which is called the origin. How to locate a point on the Cartesian plane? By taking the horizontal distance and the vertical distance. The distance of a point, in fact the horizontal distance of a point from the y-axis will give you the x coordinate, which is also known as abscissa, and the vertical distance of a point from the x-axis will give you the y-coordinate, which is also known as ordinate. If the axis of a point is x and the ordinate is y, then x comma y is known as coordinate or ordered pair. Why ordered pair? Because conventionally we write x first, the value of abscissa first and the value ordinate later in the pair. We've also learned that if a point is lying on the coordinate axis, for example, if it is lying on the x-axis, it will be of the form x comma 0. If it is lying on the y-axis, it will be of the form 0 comma y. The coordinates of the origin, where we are neither running nor rising, that means we are neither moving to the left, right or up, down, we are sticking at one point, that is the point, the central point is 0, 0. The coordinates of the point are either of the form plus plus if it's in the first quadrant, it is of the form minus plus if it is in the second quadrant, of the form minus minus in the third quadrant, and of the form plus minus in the fourth quadrant. Now, the last point, which is very important and it's very easy to remember and you can observe it also, that if x is equal to y and if x is not equal to y, what will happen? If the horizontal distance is not same as the vertical distance, then obviously x comma y will not be equal to y comma x. For example, if x is equal to minus 5 and y is equal to 3, x is not equal to 5, x is not equal to y, so my point x comma y will be minus 5, 3 and y comma x will be 3 comma minus 5, and these both are not equal. But if x is equal to y is equal to 5, then 5 comma 5 is equal to 5 comma 5. So what do we infer from here? That if the values, if the horizontal and the vertical distance are same, if the horizontal and the vertical distance are same, also in terms of sign, I cannot take one positive and one negative value. For example, if I say 5 comma minus 5, 5 is different from minus 5. If I take x to be 5 and y to be minus 5, I cannot say x and y are equal. I can say x and y are equal if I take both the values of x and y to be 5. So if I take x to be 5 and y also to be 5, and even if I interchange their orders, the point will remain unchanged. The point will remain unchanged. But if I take two different values and interchanging the positions of x and y in the ordered pair will change the quadrant. Thank you so much for watching this video, and I hope you must have learned a lot about the Cartesian planes.